So my name is Melissa Linkert, and I'd just like to spend a few minutes giving a brief overview of the past, present, and future of the OME Bioformats project. So I know some of you have used bioformats before, but for anyone who's unfamiliar, it's a Java library that reads image data from many different imaging formats. Not only does it provide unified access to the image data from over 140 different formats, but critically, it also provides access to the acquisition information that's associated with those images. All right. So in practice, this means that we have one piece of software that can give you an image, the time at which it was acquired, the objective that was used, and any other acquisition information independent of the format and in something like ImageJ, MATLAB, or any other software that supports Java. To facilitate this, the OME group maintains a standardized schema for describing acquisition metadata called OME XML, and a file format that uses OME XML called OME TIFF. Bioformats provides a complete reference implementation for both and uses the OME XML schema internally for working with acquisition metadata. Over the last few months, we've also released a new C++ library which fully supports OME XML and OME TIFF, and that may be of interest to some of you who are writing software in C++. So to give a little history, development on the Java library began here in Madison in mid-2005. So it's currently in its 10th year of active development. The first public release was in March of 2006, and the primary usage in these early days was really as a plugin for ImageJ. We didn't have a broader community at that point. Around the same time, the first versions of the Omero data management system, which some of you saw this morning, were being released. And so in late 2006, Omero began using bioformats to import files as well. In early 2008, we added official support for MATLAB through a set of example scripts, and that's evolved into a more robust MATLAB framework, which is widely used today. Also in 2008, OME XML was maturing as a standard, so we made a concerted effort to fully implement the OME XML schema and to use that as the primary means of describing the acquisition metadata that's associated with an image and contained in a file. Prior to this, metadata was stored almost exclusively in what we call the original metadata table, which is a free-form and highly format-dependent hash table. We still provide this as a supplement. Again, some of you saw this morning, but we don't really recommend this as a standard way of accessing all of your metadata. This set of changes also serve to bring bioformats fully under the OME umbrella alongside the Omero project. Development then kind of progressed for the next couple of years without major incident. We fixed a lot of bugs, we added a lot of new formats, but we soon realized that we needed a more robust way to test new versions of bioformats for regressions. So much of 2012 was spent updating, streamlining, and fully automating our testing process. So what that means today is that every single proposed bug fix, every change, anything that we decide to do is automatically tested against a 2 terabyte repository of sample data. If something breaks there, the change doesn't go in. So around the same time, and based upon feedback from the OME community, we realized that a Java library alone wasn't going to be sufficient for many people's needs. So in late 2012, early 2013, we began work on a C++ version of the Bioformats API. In parallel, we've spent much of the last couple of years improving the read time for many formats. This has been largely driven by the rise of high throughput imaging, where we're seeing data sets on the order of several terabytes. In recent months, we've noted an increased level of engagement with developers who are using bioformats. In particular, we're seeing a lot of external people who are opening GitHub pull requests. We're now seeing on average about 1 every 2 weeks. And finally, we know that many of our users are looking for more frequent releases so that you have bug fixes within a matter of days, maybe even a matter of hours, rather than the weeks or months that we have currently. To date, in 2015, we've been putting out about 1 release every month, and we're looking to make that even faster over the next several months. So for a little more quantitative look at the history, you can see in blue at the bottom here the number of contributors over time. To date in 2015, we've had 21 unique people contributing at least one Git commit. You can see at the top here in red how the number of supported formats has grown from 43 back in 2006 to 142 today. And you can see in yellow in the middle here how the number of estimated users has grown. We guess that this is about 60,000 today, but it's sort of notoriously tricky to know for sure. So with that background in mind, what can you do now? As I've mentioned, reading images and metadata is really what bioformats is all about. The early versions of bioformats focused almost exclusively on light microscopy, but as more imaging modalities have matured, as more people have started using bioformats, we've expanded to include things like electron microscopy, medical imaging, high content screening, digital pathology, FLIM, light sheet microscopy, and SPIM. We are certainly interested in adding more to that list, but it's sort of as needs arise. All of those domains still use the same software, the same API. So that means that the code to read an image and say the timestamp associated with it is going to be pretty much the same, regardless of the format and whether you're in an ImageJ macro, MATLAB, or Java code. So over the last few releases this year, we've made several notable changes to the Java library. We now have full support for Windows, so we're now testing our entire 2 terabyte repository against both Windows and Linux multiple times per week. Hand in hand with that, we've put a lot of time into improving performance over network file systems, and especially network file systems on Windows. We know we have a lot of work to do there yet, but it is getting better, I promise. We've also updated the OME XML schema and the corresponding parts of bioformats to allow the units for specific metadata values to be recorded along with the values themselves. Previously, something like the physical size of a pixel would only have been stored in micrometers, regardless of the imaging modality. Now we can store that in any standard unit based on what makes the most sense for how the acquisition was performed. Finally, we have, as always, fixed a lot of bugs. To date, in 2015, we're at about 130. I expect that number to get much, much bigger in the next few months. Many of these bugs were reported to us by the community, including many of you here. We're very grateful for this feedback. This is a huge part of what makes bioformats so powerful and so successful. Okay, so just to finish up, what's next for sort of the next 6 months or so. As I mentioned earlier, we're working on ways to update our development process so that we get more releases out more quickly. The sort of counterbalance to that is we don't want to impact quality. We have a rigorous testing process, and we need to keep that in place. We're also working to update how ROIs are stored in OME XML. Our goal is to improve the experience of opening a file, taking the ROIs out of that file, and displaying them in ImageJ or Omero. Also, in recognition of the number of developer users that we have now, we're working to update our usage examples and our developer documentation across all of the supported languages. Finally, feedback is, as always, welcome. We'd love to hear what you have to say about bioformats. If you think something is missing, if you think something doesn't work, please come talk to me or write to us on the mailing lists. That's all I have. Thank you. Any questions? Yes.
I know earlier this year there was maybe some issues with size of TIFFs and had a big TIFF sort of threshold. In general, of course, images are just getting larger and larger. So what's the new set of limits that you may be running up against in a couple of years from now?
So at the moment, we support big TIFF, which somebody can correct me if I'm wrong. It's 2 petabytes, 4 petabytes in a single file. I can't remember off the top of my head. I suspect that will hold us through for the next couple of years at least. But we'll kind of see what happens. We're certainly actively, engaged with the community. We're actively monitoring these sorts of things. And so if it looks like that's a problem, we'll certainly do what we can to address it. Anybody else? Okay, thank you.